You set your alarm for 4 hours from now. You tell yourself it's temporary, a deadline, a newborn, a flight at dawn. You lie down knowing tomorrow will hurt. But somewhere in the world right now, a small number of people are setting that same 4-hour alarm and waking up feeling completely fine, not tired, not wired on caffeine, just fine. What if the difference between you and them isn't willpower at all? Your body runs on something called sleep architecture. That's just a fancy way of saying your night isn't one long block of unconsciousness. It's a cycle. Light sleep, deep sleep, REM sleep, repeating roughly every 90 minutes. Each pass through that cycle does different work. Deep sleep, the stage that dominates the earlier cycles of the night, is when your body releases growth hormone and physically repairs tissue. REM sleep, which grows longer in each successive cycle, is when your brain sorts the day's experiences, strengthens emotional memories, and quietly discards the noise. Most nights you need 4 or 5 full cycles to feel restored. That's why 8 hours became the magic number. 4 cycles, sometimes 5, stacked back to back. But a magic number for most people isn't a law of biology. It's an average, and averages hide outliers. In 2009, a neurologist named Yinghui Fu at the University of California, San Francisco, started studying a mother and daughter who woke up naturally at 4 in the morning every single day. Not from an alarm, not from stress. Their bodies simply finished sleeping after 4 to 6 hours and refused to go back down. They weren't exhausted. They weren't irritable. They were, by every clinical measure, thriving. Fu sequenced their DNA and found something strange, a mutation on a gene called DEC2. That one gene appeared to be quietly rewriting how much sleep a human body believed it needed. Here's where it gets stranger. Fu's team later bred mice with the same mutation. The mice slept less than their litter mates and showed no signs of memory loss or physical decline. Something about that single genetic switch was letting a mammal's brain compress its nightly repair work into a shorter window. Later research out of Fu's lab identified additional genes tied to the same trait, including one called ADRB1, found in a family of short sleepers who all function normally on around 6 hours a night, generation after generation. Scientists now call people who carry variants like this natural short sleepers. Researchers estimate they make up somewhere under 1% of the population. So if you're not sleeping much and feeling terrible, the math already tells you something. You're probably not one of them. So why does the myth persist? Why do so many high performers brag about running on 4 hours? Some of it is theater. Powerful people like to signal that they need less than everyone else. It reads as strength. But sleep researcher Matthew Walker at the University of California, Berkeley, has spent years pushing back against that story. His work shows that chronic short sleep in ordinary people is linked to measurable declines in memory consolidation, immune function, and even long-term cardiovascular health. The body isn't lying dormant while you sleep, it's running maintenance, clearing waste proteins from the brain, repairing muscle tissue, locking new memories into long-term storage. Skip that maintenance long enough and the debt doesn't disappear. It compounds. But there's a second piece to this puzzle, and it isn't genetic at all. It's historical. Go back before electric light existed anywhere on Earth. A historian named Roger E. Kirch spent over a decade digging through diaries, court records, and medical texts from pre-industrial Europe. He found hundreds of casual references to something called first sleep and second sleep. People would go to bed shortly after dark, sleep for a few hours, then wake naturally in the middle of the night. They'd pray, talk, have sex, tend the fire, even visit neighbors. Then they'd drift into a second sleep until dawn. This wasn't insomnia. It was simply how humans slept, before artificial light stretched the evening and pushed bedtime later. In the 1990s, psychiatrist Thomas Ware ran an experiment that accidentally recreated this pattern. He put a group of volunteers in a room with 14 hours of darkness every night, no clocks, no artificial light, for a full month. At first, the volunteers simply slept longer, as if paying off a debt they hadn't realized they were carrying. But within weeks, their sleep settled into something unexpected. It split on its own into 2 distinct blocks, separated by an hour or two of quiet wakefulness in the middle of the night. During that waking window, VAERS subjects described a state of calm, almost meditative alertness, unlike anything they experienced during a normal day. Their bodies, freed from modern lighting, had rediscovered a rhythm their ancestors used for most of human history. So what does a DEC2 mutation from 2009 have to do with candlelit villages from 400 years ago? Everything, actually. Both stories point to the same underlying truth. Sleep length is negotiable, sleep quality is not. The rare short sleepers aren't beating the system by needing less repair. Their biology genuinely does the repair work faster and more efficiently, cycle for cycle. The pre-industrial villagers weren't sleeping less either. Add their first sleep and second sleep together and you land right back around 8 hours, just split by a strange nocturnal intermission. Which brings us to the people who try to hack their way into that 4-hour club without the gene for it. This is where polyphasic sleep schedules come in. Splitting sleep into 6 or 8 short naps across a full 24 hours, chasing that same total window as the rare short sleepers, but broken into fragments. In theory, it sounds efficient. In practice, most people who attempt it struggle badly within days. Why? Because REM sleep, the stage most tied to memory and emotional regulation, doesn't arrive evenly across a day. It clusters more heavily in the later sleep cycles, the ones closest to your natural wake time. Chop your night into fragments and you often cut off access to exactly the stage your brain needs most. Researchers studying polyphasic schedules have consistently found that most practitioners quietly abandon them, and that cognitive performance measurably drops for those who push through. There's also a quieter problem hiding underneath all of this. You might not even notice you're impaired. Sleep researchers call this the paradox of sleep debt. Your subjective sense of tiredness plateaus after a few days of restriction, even while your actual cognitive performance keeps sliding. A well-known study led by David Dinges at the University of Pennsylvania restricted volunteers to 6 hours of sleep a night for 2 weeks straight. The participants insisted they felt only mildly tired, but their reaction times and attention scores kept declining day after day until they matched people who had been kept awake for 24 hours straight. They felt fine. They were not fine. The brain, it turns out, is a poor judge of its own exhaustion. That gap between how tired you feel and how impaired you actually are explains a lot about modern life. It explains why a founder can genuinely believe 4 hours of sleep is working for them, right up until a decision they'd never normally make slips out under pressure. It explains why caffeine feels like a fix instead of a mask. Caffeine doesn't restore lost sleep stages. It blocks a molecule called adenosine, the one your brain uses to signal accumulating tiredness. Block the messenger and the message doesn't arrive. The debt is still there. You've just muted the notification. So the 4-hour dream mostly comes down to one of 3 things: a rare genetic variant almost nobody has, a historical sleep pattern your ancestors used that still totals close to 8 hours, or a fragmented schedule that looks efficient on paper and quietly erodes your mind in practice. None of that means your sleep habits are fixed and hopeless, though. What actually moves the needle for most people isn't shaving hours off the clock. It's sleep efficiency, the percentage of time in bed you actually spend asleep, as opposed to lying there scrolling, tossing, or staring at the ceiling. A person who spends 7 hours in bed and sleeps for 6.5 is, in a strange sense, sleeping more effectively than someone who spends 9 hours in bed and only sleeps for 7. The clock isn't the whole story. The quality of the time inside it is. Consistent bedtimes matter more than most people expect. Your body runs on a roughly 24-hour internal clock, regulated by a cluster of neurons behind your eyes called the suprachiasmatic nucleus. That clock doesn't just track when to sleep. It pre-schedules your entire sleep architecture, deciding in advance when deep sleep and REM sleep should arrive. Push your bedtime around by 2 or 3 hours every night, and you're asking that internal clock to redraw its blueprint from scratch every single day. A cool dark room helps too, because your core body temperature has to drop for sleep onset to begin, and light of almost any kind, especially the blue wavelengths from a phone screen, suppresses the release of melatonin, the hormone that signals night has arrived. None of these changes will turn you into a natural short sleeper, but they can shrink the gap between the hours you spend in bed and the hours you spend actually repairing. Here's the quiet twist in all of this. The people who function on 4 hours aren't proof that sleep is optional, they're proof of exactly the opposite. Their bodies still complete every essential stage of sleep architecture, every cycle of deep repair and REM sorting your own brain depends on. They just do it faster, more efficiently, cycle after cycle, thanks to a rewrite in their DNA that the rest of us don't carry. Everyone else, including every exhausted founder bragging about their 4 a.m. wake-ups, is running on borrowed time, not discovered efficiency. The debt doesn't vanish just because the sensation of tiredness fades into the background. It waits. Quietly, in your reaction time, your memory, your patience with the people around you. So tonight, when you set that alarm for 4 hours from now and tell yourself it's temporary, remember what your ancestors already knew by candlelight and what a mother and daughter in a San Francisco lab accidentally proved. Your brain isn't broken for needing rest. It's doing exactly what it evolved to do, stage by stage, cycle by cycle, whether you grant it the time or not. The only question left is whether you'll give it the time it actually asks for, or hand it 4 hours and call it 8.